Now what we are going to do is we are going to run a regression analysis for multiple and create a multiple linear regression model. When we are doing this, we will have more than two variables, right? We still have revenue as our dependent variable, our y, and we will have more than one independent or x variable. This is where we know we have to run a multiple linear regression model. So once again, we can graph the data and take a look if you'd like. And we see that, oh, there's these two different data points, right? You have scatter plot data here, you have scatter plot data here. You can graph them independently as well. That would also be satisfactory. But the main thing is to see here is that you have more than one dependent variable. You have more than one independent variable. So the x variable. So you have to run a multiple linear regression model, which cannot be done using the graphical method. Okay, we cannot do it this way because you will actually do multiple single linear regressions rather than the multiple regression. So when you have the case here for multiple linear regression, you cannot do it graphically. So we are going to have to do it using that data analysis, regression analysis. So the way to do that is to go to data, click data analysis, regression, click OK. Now we input our Y range, which is all of this information here. And this time I'm going to include revenues as the label. And here, input the X range. You want to include all of your X variables, including if you had more here, you would include all of that. But we are only doing two here. But if we had a third, fourth, we could include all of that. So let's go down here. That includes everything there. In this case, I have included these as labels, so I will check mark that off. And let's put the output there is fine. Click OK. All right. Here is our analysis. The R-squared value of this multiple linear regression model is 0.59, which is much better than the single linear regression value we got last time, but still not as high as we would like, right? Like a really good model would be 0.75 or more. What's interesting here is we get additional data, right? We get additional data in terms of, the significance value, but also very interestingly, we get the p-values and we also get coefficients, okay? The interesting part about the p-values is the p-value that has the lowest p-value is the independent variable which is influencing them or having the most impact on the predictive model. In the case here, this p-value for website traffic has the lowest p-value, which means that in this multiple linear regression model, website traffic is by far the most influential or the most important independent variable that is impacting the model here. This is important if you had multiple independent variables and you wanted to kind of prioritize and say which independent variable had a significantly more impact on the model. And then the way to do that is to look at the independent variable that has the lowest p-value to know that that is the number one, that is the most influential, the independent variable that is having the most influence on the model. The other important thing is that these coefficient numbers actually can be used to develop the regression model, the y is equal to mx plus b model for multiple linear regression. So, for example, the intercept value right here, that is the plus b, the intercept. In this case is minus 52, right? And then you also have the other variables here as well. So if you wanted to technically create an equation, you could create an equation and say revenue is equal to like mx, so slope, right? So we can do the slope as, which is one of the coefficients, so let's say 28 times website traffic, web traffic, mx, plus the other mx, so 47. So 47 is the slope for this one, right? From the coefficient here, applies employee engagement, plus b, but in this case is a negative, so minus the intercept, which is 52. That will be our multiple linear regression model in this case. What I've done here is basically expanded y is equal to m1 x1 plus m2 x2 plus b, which is the y intercept.